Hey everyone! So in this video, I would like to take a look at rotations, another one of our transformations. And what I would like to do is take a look at our mathematical definition of what a rotation is, and then I want to go through that definition, put a diagram with it so we can make sense of what it's trying to say. And after taking a look at the definition, I want to do just a real simple example where we're going to use the definition to help us develop some coordinate rules, some shortcuts, that we can use to help us do rotations in the coordinate plane. And then after we've developed those rules, we're going to take those and let's apply them in a specific example. So the first thing, let's take a look at what the definition of a rotation says. It says a rotation about a point P through an angle of x degrees maps every point Q in the plane to a point Q prime so that one of the following properties is true. The first property says if Q is not the center, so if Q is not the same as point P, then the length from Q to P is the same as the length from Q prime to P. And then the angle that is formed by those 3 points, Q, P, and Q prime, that's our angle of rotation, so that's going to be x degrees. And then the second case, this one's much simpler. If Q is the center, so if Q is on top of point P, then it doesn't move. It just rotates on top of itself, so Q and Q prime are the same. So there's a lot going on here. So I'd like to go back to the beginning of the definition and then start building a diagram to help us make sense of what this is saying. So the first thing, a rotation about a point P. So let's draw a point P somewhere in space. This is going to be our center of rotation. So every other point in our coordinate plane or in our space is going to rotate around this point. Then our rotation is going to happen through an angle of x degrees. We'll come back to that in a second. But our rotation maps every point Q to a new point Q prime. So Q is our pre-image and Q prime is our image. So just to demonstrate our first property here, which is the more interesting one, let's draw another point not on P, and we'll call this one Q. So the first property says if Q is not the center, so that's the one we want to take a look at, then the length from Q to P, so that's the segment length that connects Q to our center of rotation P. So this segment here, that length has to be exactly the same as the length from our image to our center of rotation. So when we rotate Q, it's going to stay the same distance away from that center of rotation. One thing I can do is I can think about Q as if it's traveling along a circle. So if I draw in the circle here, we know that the radius of a circle is the same everywhere. P is like the center of this circle. So when I do my rotation, Q prime is going to end up somewhere on this circle. So maybe we'll put it over here and we'll call this Q prime. And now if I connect together Q prime with my center of rotation, because we set this up within a circle, we know that these two segments are congruent. So the length from Q to P is the same as the length from Q prime to P. And now we have an angle. So we have an angle that goes from Q to our center of rotation P to our image Q prime. This angle, this has a measure of x degrees, and we call that our angle of rotation. So that's what the definition says. So it's taking any point Q, no matter where it is, it's rotating it around this center of rotation that we're calling P, and it's doing it at an angle of x degrees, and again, that can be anything. So now that we have a sense of what the definition says, let's take a look at a real simple example and see if we can develop some shortcuts that can help us out. So I just want to take a point R, so I have the point 4, 2. So let me graph that right away. 1, 2, 3, 4, and up 2. So here's point R. And I want to do a couple rotations with this. So I want to rotate it 90 degrees. I want to rotate it 180 degrees and 270. these are the most common angles of rotation. And hopefully we notice something about our images, R prime, that will allow us to develop some shortcuts so we can make doing rotations in the coordinate plane much easier. All right, so let's start with the rotation of 90 degrees. And I want to apply our definition here. So the first thing, we're going to rotate this about the origin. So we're going to rotate this about the point 0, 0. So I'm going to just draw this in. I'm going to label it O for origin. Now, the first part of the definition, we said that the distance from the center of rotation to our point, that's going to stay the same. So this length here, that's going to stay the same. And as I said, we could think about it as if we're rotating along a circle. Next, we need to make sure that our angle of rotation is 90 degrees. So the angle that's formed by this segment we have drawn in, and then our second segment that we're going to connect to R prime, these two segments have to form a right angle. Well, in the coordinate plane, I know that segments that have opposite reciprocal slopes, I know that those are going to be perpendicular. They're going to form that right angle. So let's take a look at the slope of this segment from my origin to the point R. So the slope, I go up 1 over 2, up 1 over 2, that's a slope of 1/2. So to be perpendicular to that, I'm going to need a slope of -2. So I'm going to rotate this counterclockwise. So in general, I know I'm going to end up somewhere over in this quadrant here. I'm going to use my slope to figure out where this point is going to be. So the slope of -2, just working my way backwards, and I end up with a point right here. So this is my first one. This is going to be my first R prime. And if I connect that together with a segment to the origin, I should see that these two segments do in fact form a right angle. So we got the right angle here, and the coordinates of this first one. So our first one, we had R, it went from 4, 2, we did our rotation, and then R prime ended up at -2, 4. Okay, now the next one, the rotation of 180 degrees, we're still going to end up somewhere on this circle, but now we want this angle of rotation to be 180, which means that our two segments are going to form a straight line. So if I just take the segment I already have drawn in, and I just extend this out to form that straight angle of 180 degrees, again, because it's on the circle, I know that this is going to be the same distance, so these two segments are congruent to each other. And then right here, this is going to be my image. I'm going to just call this one R double prime. So for the rotation of 180, we went from the point 4, 2, and now taking a look, we have coordinates here at -4 and -2. And the last one, the rotation of 270 degrees. So now we're going to go 90, 180, 90 more degrees will get me to my last rotation. So if I think about my rotation of 90, the 271 is going to form a straight angle with that segment. So I can just go through here, draw in our last segment, extend this one out. It's going to go to right here. I could use these slopes again. Remember, our original slope from the origin to R was 1/2. So using my opposite reciprocal slope of -2, I can go down 2 over 1, down 2 over 1, and that's going to be my last point. And let's just call this one R triple prime just to differentiate it. So for that last one, we went from the point R 4, 2, and now our new coordinates looks like we are at the point 2, -4. And hopefully you can see they all ended up on the circle, and in each case, the angle of rotation, we have nice perpendiculars forming right angles or forming straight angles. But now let's take a look at what we ended up with for our results, and let's see if we can generalize this and come up with some shortcuts that will help us out. So to be general, we want to use a general point. So we're going to use some variables. So instead of putting numbers in here, I'm going to take a look at the point AB. And now let's go back to our 90-degree rotation and look to see what happened here. So we went from 4, 2 to negative 2, 4. So it looks like the 4 and the 2 switched spots, and then the 2 became negative. So if this was AB, now they're going to switch spots, so B and A, but then this first one became negative. So my shortcut is going to be negative B, A. For the rotation of 180 degrees, we take a look. So the 4 and the 2 stayed in the same positions, but now they're both negative. So A and B will stay in the same spots, but we're going to add negative signs to both of them. And then our last one for 270, let's take a look to see what happened to these. 4 and 2, again they switch spots, so now it's 2 and now negative 4. So if we start with AB, they switch spots again, but now the second one, so A, becomes negative. And here's some shortcuts. They're general, we're using variables, and these will work for any point that we're given. Okay, so now that we have these rules, let's apply these in a specific example. So I have a quadrilateral RSTU with the following coordinates. R is 3, negative 1, S is 6, negative 1, T is 6, negative 5, and U is 3, negative 4. And I want to graph that quadrilateral and its image after rotation of 180 degrees. So let's start by graphing our quadrilateral. So R is 3, negative 1. S is going to be 6, negative 1, so 3, 4, 5, 6, down 1. T is 6, negative 5, so here 1, 2, 3, 4, 5 units down. And our last point, U is 3, negative 4, so 1, 2, 3, and then 1, 2, 3, 4. So let me label these. We have R, S, T, and U. I'm just going to connect these together to form our quadrilateral. All right, so here's our quadrilateral. It's down in quadrant 4, and we want to do a rotation of 180 degrees. We're always going to rotate counterclockwise unless it tells us differently. So if I think about where this quadrilateral is going to end up, I'm going to take RSTU and I'm going to rotate it about the origin. So we're going to spin it around this point here. So 90 degrees, I'll end up in quadrant 1. And if I go 90 more to do a rotation of 180, I'll end up over here in quadrant 2. So right away, just knowing where this is going to end up gives me a good idea of what my final graph is going to end up looking like. So now, the shortcut we came up with for 180 degree rotation, our points go from AB to negative A, negative B. So let's just algebraically, let's follow along to see what happens to our points. So the point's 3, negative 1. To get to my image, R prime, we're just going to switch the signs on the X and the Y coordinate. So we end up with negative 3, positive 1. And let's do the same thing for the remaining points. So S, 6, negative 1, that's going to change to S prime, 6, and positive 1. Let's see, T is the point 6, negative 5. Switching the signs on the X and the Y coordinates, we get negative 6, positive 5. And the last one for U, 3, negative 4. Switching those signs for U prime, we get negative 3, positive 4. Now if we graph these, hopefully we end up with something that looks similar to what we started with, but it's going to be rotated 180 degrees. So let's find out. So R prime, negative 3, positive 1. S prime is negative 6, positive 1. T prime, negative 6, positive 5. 1, 2, 3, 4, 5. And then lastly, U prime, negative 3, positive 4. 1, 2, 3, and 4. So let me connect these together to form our quadrilateral. And here's our image. So as we can see, all the points should be the same distance away from the origin. We can test that by drawing a circle. So let me just draw a circle through, starting at the origin and then through R and R prime. And we can see that r and r prime both are on the circle, so the distances are staying the same, which is good for our rotation. And then the second thing, we can see that the orientation of our quadrilateral changed. Segment RS was sort of on the top of our quadrilateral, but now since I rotated it 180 degrees, now that segment R prime S prime is along the bottom. So there are the basics about rotations. We took a look at the definition, we made sense of it. We used the definition to help us develop some shortcuts that we can use in examples like this, making it much easier to graph rotations in the coordinate plane.